Aquillone is an individual research organization based in Japan. We focus on the theory of everything. Also, we create fascinating ideas to accelerate the technological growth of Type 1 civilization. We are creating favorable conditions for the human society to enter the next stage of evolution. In all our videos, you can find some interesting new ideas. So in this video, we are going to discuss how we can solve the Baryon asymmetry problem. The Baryon asymmetry problem is that after the Big Bang, instead of particles and antiparticles having to be created in the same amount, the particles become created slightly more numerous. Now we will see why did this happen. After the Big Bang, at the baryon synthesis period, the particles were created in pairs like particles and antiparticles. These are so contradictory in nature that they collide with each other and were destroyed. This is one of the unsolved problems in physics. We call this as baryon annihilation or matter-antimatter annihilation problem. If things are going in this way, then the universe we see today would never be formed. But the whole universe is made up of matter or particles. For this to happen, there must be more particles than antiparticles. Let us see what is the main reason for this to happen. If the Big Bang took place in a state of equilibrium between space-time and energy, this state of affairs like baryon asymmetry would not have arisen. Many say that there was no time before the Big Bang. This is a misconception. The Big Bang singularity was not formed in just a moment. It took billions of years to store this much energy in the Big Bang singularity. We had already done a video about it, named Was There a Time Before the Big Bang? You can check it with our channel. The key point here we are discussing is that we must understand matter always holds some proportion of space-time with the energy contained in it. Without space-time, matter cannot exist. Even if it is a singularity or a fundamental particle, it must hold some proportion of space-time according to the energy stored in it. So let us consider the singularity as a system with full of energy and space-time under its influence as another system. Let us consider our universe as a common system where these two systems come together. Now we can see the universe is the combination of the distribution of two different systems. Suppose that these two systems are distributed in equal proportions inside the universe. In this condition, the universe is in a state of equilibrium. A balanced universe will never try to change itself. If that happens, it is likely to upset its equilibrium. So the early universe must be in an imbalanced state. So any one of these two parts of the system must be slightly more than the other. Many of the phenomena that follow the Big Bang and the inflation are the evidence that the proportion of the space-time and the distribution of energy in the universe were unequal. Similarly, if particles are formed within a balanced system, they will always form in pairs. But here we can see that the number of particles is greater than the number of antiparticles. An imbalance in the ratio between energy and space-time can create an imbalance in the ratio between the formation of particles and antiparticles. So we can say that the distribution of energy in the universe is slightly larger than the distribution of space-time. The mathematical description of this system is in our other video, the unification theory. I will add it to the end card of this video. Also, you can see a detailed explanation of the universe in our book, Key to the Secrets of the Universe. There we explain the universe from its early state before the Big Bang. There you can see the beginning of the universe from the primordial collision of two primordial particles for the formation of a singularity. Or you can visit our website for more information. All the links for the book and our website is in the description box. Now let us get back to our topic. So we can take our early universe as the evidence. In the early universe, the baryon synthesis period, the difference between particle pairs and free particles were very small. We can see this difference in the period of origin of particles after the Big Bang. An independent particle formed only when there about 1 billion pairs of particles were created. So we cannot see this as a large scale imbalance. Therefore, it can be seen that the difference in the ratio of space-time to the energy in the universe is very small. This difference is the main reason for the Big Bang to be happen at that particular moment. Inflationary epochs can also be explained in the same way. I think you get the idea. Thank you for watching our video.